So here it is told that identify the pair of physical quantities that have same dimensions: velocity gradient and decay constant. So velocity gradient is dv by dx. It means it is velocity by length. Change in velocity by length, that is lt power minus 1 by l. So it is t power minus 1. And decay constant is lambda, which is you can see that is um, minus dn by dt, that is equal to lambda times n, where lambda is the decay constant. So the dimensional formula for lambda is also t power minus 1. So they have the same dimensions. And Wein's constant is lambda m into t equals to b. So Wein's constant, that is b, its dimension is lambda, that is L, into T is temperature, so that is Kelvin. And Stephen's constant is intensity, that is sigma A T power 4. So obviously it will not be the same. The dimensional formula for sigma, which is Stephen's constant, that is the intensity, that is equal to sigma A T power 4. In, or so it is equal to the energy, the radiation energy by time, which is the power of the electromagnetic radiation. So this will be mlt power minus 2 L square by time, that is t power minus 3 by a, that is L square into t. T is Kelvin power 4. So obviously the Wein's constant and the Stephen's constant is not having the same dimensions. Then angular frequency omega, its dimensional formula is also t power minus 1. And angular momentum, its dimensional formula is r cross p, so it is ml square t power minus 1. So that is also not same. And wave number, that is k, wave number, its dimensional formula is L power minus 1. And Avogadro number, it is dimensionless. So it means only velocity gradient and decay constant, they are having the same dimensions. So option A is the correct answer. Then here it is told identify the pair of physical quantities which have different dimensions: wave number and Rydberg's constant. Identify the pair of physical quantities which have different dimensions: wave number wave number, its dimensional formula is L power minus 1. And Rydberg constant, it is and the wave number, that is new bar, that is equal to rz square into 1 by n1 minus 1 by n2. So Rydberg constant also will have the same dimension, that is angular, which is the wave number, that is L power minus 1. And stress is having the dimensional formula for stress, that is force by area, that is M L power minus 1 T power minus 2. And coefficient of elasticity, that is suppose the modulus of elasticity, which is Young's modulus, that will be also same as that of stress. So its dimension is same as that of stress. And cursivity and magnetization, so the magnetization M, and in the D, that is specific heat capacity. Specific heat capacity, we know that Q equals to mst. So specific heat capacity, its dimension is heat energy, that is ml square T power minus 2 by m mass into temperature. So that is L square T power minus 2 K power minus 1. And the dimension for latent heat, that is L, that will be equal to Q by M, that is ml square T power minus 2 by M. So that is L square T power minus 2. So it means that specific heat capacity and latent heat, they are having different dimensions. So option D is the correct answer. And magnetization and cursivity, they also have the same dimension, which is magnetization, that is equal to the net magnetic m- m- moment per unit volume, that is called magnetization. The net magnetic moment per unit volume. So the net magnetic mo moment, that will be equal to mm, also I can say, okay, so magnetic moment, I can say that is equal to NIA, which is equal to current into area by volume. So the dimension for magnetization, let's call it as M1. So that will be current, that is A into area, that is L square by volume by L cube. So that will be AL power minus 1. And for cursivity also, it will be having the same dimensions. Then here it is told a student determined Young's modulus of elasticity using the formula y equals to mg L cube by 4b d cube delta. The value of g is taken to be 9.8 meter per second square without any significant e- error. His observations are as following. So then the fractional error in the measurement of y is. So from here we can say the fractional error in the measurement of y, that is delta y by y, that will be equal to delta m by m, which is the fractional error or the relative error in the measurement of mass plus relative error in the measurement of g plus 3 into relative error in the measurement of the length of the bar plus relative error in the measurement of breadth of the bar plus 3 into relative error in the measurement of the thickness of the bar plus relative error in the measurement of depression of the bar. Okay. So therefore, delta y by y, that only we have to find. So delta m is least count is 1 gram. Least count is 1 gram divided by the mass m is 2 kg, so it is 2000 gram. 2000 plus delta g. Delta g is the value of g is taken to be 9.8 meter per second square without any significant error. So it means that the g value that has no error means delta g is approximately 0. So it will be 0 by 9.8 plus 3 into delta L by L. Now delta L is the least count, that is 1 millimeter. 1 millimeter divided by the length, that is 1 meter. 1 meter I can say 1000 millimeter plus that is delta B. Delta B is 0.1 millimeter. 0.1 millimeter divided by B is 4 centimeter. So 440 millimeter plus 3 into the depth. So error in the depth, that is 0.01 millimeter. 0.01 millimeter divided by the value of D, that is 0.4 centimeter. So I can tell 4 millimeter plus that is the delta y, delta which is delta the relative error in depression. So the least count for the depression, that is 0.01 millimeter divided by the value is 5 millimeter. 5 millimeter. So this value we have to find out. So that will be 1 by 2000, which is 0.5 divided by 1000, that is 10 power 3 plus 0 plus 3 by 1000, that is 0.003 plus 1 by 400 is 0.01 by 4 plus 0.03 by 4 plus 0.01 by 5. Is 0.010, okay. 0.0005 plus 0.003 plus this will be 4, that is 425 is 100, that is 0.0025 plus this will be 0.0075 plus this will be 0.002. So if we add them, then we will get, so the fourth decimal place, that is 5, 5, 3s are 15, 1, and the third decimal place, which is 2 plus 7, that is 9, 9 plus 2, 11, 11 plus 3, 14. 14 plus 1, 15, 1. In the second decimal place, that is 1, so 0. So 0.0155. 0.0155. So option B is the correct answer. Then here it is told, in an experiment to find acceleration due to gravity using simple pendulum, the time period of 0.5 second is measured from time of 100 oscillations with a watch of 1 second resolution. If measured value of length is 10 centimeter known to 1 millimeter accuracy, the accuracy in the determination of G is found to be x%, the value of x is. So G, as we know, so it's actually the time period is 2 pi root over L by G. So therefore I can say G value will be equal to 4 pi square L by T square. So therefore the percentage error in the measurement of G, that will be equal to the percentage error in the measurement of L plus twice of the percentage error in the measurement of T. So here the delta L value, that is 1 millimeter, that is 10, that is 1 by 10 centimeter, that is 0.1 centimeter. So 0.1 by 1 by 10 into 100% plus 2 into delta T, that is, so this T actually the time period, that is the time of 100 oscillations, so that will be T by 100 you have to take. So the resolution is 1 second. Time period of it means that time period is 0.5 second, but in 100 oscillations it will take 50 seconds. So 1 second by 50 seconds into 100%. Since why here the least count will be 1 by 100. Least count delta T, that will be 1 by 100, since it is measured from the time of 100 oscillations and T is 0.5 seconds. So if we do delta T by T, then we will get 1 by 50. So this we have to solve. So then we will get 1% plus 50 to the 100. So 2 to the 4%. So that is equal to 5%. So the percentage error in the or the accuracy in the determination of G is 5%. So X will be equal to 5. And here it is told the one division of main scale of vernier calipers reads 1 millimeter and 10 divisions of so it means one main scale division is 1 millimeter, or I can say 0.1 centimeter, and 10 divisions of vernier scale is equal to 9 divisions of main scale. So 10 vernier scale divisions equal to 9 main scale divisions. So 1 vernier scale division, that is equal to 9 by 10 main scale division. So that will be 9 by 10 into 0.1 centimeter, that is equal to 0.09 centimeter. So, and when the two jaws of the instrument touch each other, the zero of the vernier lies to the right of the zero of the main scale, and its fourth division coincides with the main scale division. So therefore, here we have negative zero error. Negative zero error. So that will be equal to minus of 10 minus the fourth division coincides. So 10 minus 4 into the least count. And then it is told when a spherical bob is tightly packed, is tightly placed in between the two jaws, the zero of the vernier scale lies in between 4.1 centimeter and 4.2 centimeter, and sixth vernier division coincides with the main scale division. The diameter of the bob will be, so now therefore the least count, that is 1 main scale division minus 1 vernier scale division, so that will be 0.1 centimeter minus 0.09 centimeter, so that will be 0.01 centimeter. Therefore the negative zero error negative 0 error, that will be equal to minus 6 into 0.01 centimeter. So that is minus 0.06 centimeter. And then here it is told the when the spherical bob is placed in between the two jaws, then here the main scale reading is 4.1 centimeter. Since it is told the zero lies in between 4.1 and 4.2 centimeter, and the vernier coincidence, that is equal to the sixth division. So therefore the vernier scale reading, that is the vernier coincidence times the least count, so that is 6 into 0.01 centimeter, so that is 0.06 centimeter. So now therefore the observed reading of the diameter of the bob, observed reading, that is equal to main scale reading plus vernier scale reading, so that is 4.1 centimeter plus 0.06 centimeter, which is 4.16 centimeter, and the negative 0 error is minus 0.06 centimeter. So therefore the actual diameter of the bob, that is 4.16 centimeter, which is the observed reading, minus the 0 error, which is minus 0.06 centimeter. So this will be 4.16 plus 0.06 centimeter, so that will be 4.22 centimeter. 4.22 centimeter. So therefore the actual diameter of the bob is, I can tell, 422 into 10 power minus 2 centimeter. Then here it is told the vernier constant of vernier calipers is 0.1 millimeter. Vernier constant. So vernier constant, it means the least count of the vernier calipers, that is 0.1 millimeter, or I can say 0.01 centimeter, and it's negative. There is a negative 0 error for this instrument, that is minus 0.05 centimeter. While measuring the diameter of a sphere, the main scale reading is 1.7 centimeter, and coinciding vernier division is 5. So the vernier coincidence is 5. So the vernier scale reading will be vernier coincidence into the vernier constant or the least count. So vernier coincidence is 5 into 0.01 centimeter, so that is 0.05 centimeter. Now therefore the observed reading, of the diameter of the sphere, observed reading of the for the diameter of the sphere, so that will be observed reading of the diameter of the sphere, that is main scale reading plus vernier scale reading. So the main scale reading, that will be 1.7 centimeter plus 0.05 centimeter, so that will be 1.75 centimeter, and therefore the actual corrected diameter, the corrected reading or the corrected diameter of the bob, that the corrected diameter of the sphere, that will be equal to the observed reading minus the zero error, so that will be equal to the actual diameter, that is 1.75 centimeter minus 0.05 centimeter, which is the negative zero error of this vernier calipers. So if we add them, then we will get 1.75 plus 0.05 centimeter, so that will be equal to 1.8 centimeter, 1.80 centimeter, or I can write it as 180 into 10 power minus 2 centimeter. And here it is told a student in the laboratory measures thickness of a wire using screw gauge. The readings are 1.22 millimeter, 1.23 millimeter, 1.19 millimeter and 1.20 millimeter. The percentage error is x by 121%. Okay. So therefore, m- m- measuring the thickness of a wire using screw gauge. So the percentage error. So here we have to, so the length or the thickness of the wire, let's call it as thickness is B, suppose. So B, let's say the thickness is X. So the X will be equal to the average of the four readings, that is x1 plus x2 plus x3 plus x4 divided by 4. So now therefore the error, the absolute error in the measurement, that will be delta x, that will be delta x1 plus delta x2 plus delta x3 plus delta x4 divided by 4. So now the error, maximum error is the least count of the screw gauge. So the least count of screw gauge, we know that is equal to 0.001 centimeter. So this will be 0.00, or I can say 0.01 millimeter. So this will be 0.01 into 4 divided by 4, this much millimeter. So that is 0.01 millimeter. And the reading for the thickness of the wire x, that will be equal to x1 plus x2 plus x3 by 4. So x will be equal to 1.22 plus 1.23 plus 1.19 plus 1.20 divided by 4. So this will be equal to 4 point, if we add 9 plus 3, 12 plus 2, 14, 1, 1, 2 for the 8, 4.84 divided by 4. So that will be 1.21 millimeter. So therefore the percentage error we have to find. Therefore the percentage error, that will be equal to delta x by x into 100%. So delta x is 0.01 millimeter divided by x is 1.21 millimeter into 100%. So this will be equal to 1 by 121. So it is 100 by 121%. So the value of x that will be, x will be equal to 100. This x here, this x is ours, that is equal to 100. And here let's call this as x naught, suppose x naught, else we may get confused. Okay, so this will be equal to delta x by x naught into 100% of it. Then here it is told that a traveling microscope is used to uh, determine the refractive index of a glass slab if 40 divisions are there in 1 centimeter on main scale. So it means 40 main scale divisions, that is equal to 1 centimeter. So it means 1 main scale division, that is equal to 1 by 40 centimeter. And 50 vernier scale divisions are equal to 49 main scale divisions. Then least count of the traveling microscope is. So therefore 1 vernier scale division, that will be equal to 49 by 50 main scale divisions. So now therefore the least count of the traveling microscope, least count of the microscope which is obviously a vernier calipers. So that will be equal to 1 main scale division minus 1 vernier scale division. So 1 main scale division, it is 1 by 40 centimeter, and 1 vernier scale division, that is 49 by 50 into the so here it is told that if 40 divisions are there in 1 centimeter on the main scale, it means that 40 main scale divisions, that is equals to 1 centimeter, and 50 vernier scale divisions, that is equal to 49 main scale divisions. Then the least count of the traveling microscope is, so therefore the least count that we know, that is equal to 1 main scale division minus 1 vernier scale division. So 1 main scale division, that is 1 by 40 centimeter, minus 1 vernier scale division, I can say that will be equal to 49 by 50 main scale division. That means it is 49 by 50 into 40 centimeter. This is 49 by, so it is by 4, that 50 into 40 centimeters. So the from here 1 by 40 I can take as common, and then it will be 1 minus 49 by 50 centimeter. So this will be 1 by 40 into 1 by 50 centimeter. So that will be equal to 1 by 4 for the 20, so 1 by 2000 centimeter. So this I can say it is 1 centimeter is 10 power minus 2 meter, since 1 meter is 100 centimeters. So 1 centimeter is 10 power minus 2 meter. So this is 10 power minus 2 divided by 2000. So that is, this I can say 10 power, so 10,000 into 10 power minus 6 by 2000 centimeter, no, meter. So this will be 5 into 10 power minus 6 meter. So this is the required least count. So in the blank we should write 5. Then here it is told, in a vernier calipers, each centimeter on the main scale is divided into 20 equal parts. So 20 main scale divisions, that is equal to 1 centimeter on the main scale. If the 10th vernier scale division that coincides with the 9th main scale division, then the value of the vernier constant will be, so 1 vernier scale division, that is equal to 9 by 10 main scale division. So therefore the vernier constant means the least count that we have to find. So 1 main scale division, that is equal to 1 by 20 centimeter. So therefore 1 vernier scale division, that is 9 by 200 centimeter. 9 by 10 into 1 by 20. So therefore the least count or the vernier constant, that will be equal to 1 main scale division minus 1 vernier scale division. So that will be equal to 1 by 20 centimeter minus 9 by 200 centimeter. So that will be 1 by 20 into 1 minus 9 by 10 centimeters. So that will be equal to 1 by 200 centimeters. So this will be equal to, so in millimeter it has been asked. So 1 centimeter is 10 millimeter. So this is 10 by 200 millimeter. So this will be equal to 2 5s are 10, 100. So 5 into 10 power minus 2 millimeter. So in the blank we should write 5. Then here it is told, if z equals to a square x cube y power half, then where a is a constant, if percentage error in measurement of x and y are 4% and 12% respectively, and the percentage error for z will be, so a square is a constant, so therefore I can say that z is proportional to x cube y power half. Therefore the percentage error in z, that will be equal to 3 times the percentage error in x, 3 times the percentage error in x plus half times the percentage error in y. So this will be 3 times now the percentage error in x, that is 4%. So 3 into 4% plus half into the percentage error in y, that is 12%. So this will be 12 plus, so 2 6 are 12, that is 6%. So that is 18%. So the percentage error in z will be 18%. Then here it is told, if velocity, time, and force are chosen as the base units, the dimensions of the mass will be. So as we know that, uh, so mass, so force, as we know, that is equal to mlt power minus 2. So this you can tell it is mass into lt power minus 1 by t. So lt power minus 1 is the dimension for velocity. So I can say force equals to mass into velocity by time. So therefore mass, we can say it is force into time by velocity. So therefore the dimension of mass, that will be equal to force into time into velocity power minus 1 into into v inverse. So option B is the correct answer. Then here it is told torque, we have to find the dimensional formula for torque. So torque, as we know, that is equal to force into length, since y it is r cross f. So therefore the dimensional formula for torque, that will be equal to force ml squared t power minus 2. So A will match with 3. And impulse is change in momentum, or I can say it is force into time. So that is ml t power minus 1. So B will match with 1. And C is tension. So the dimensional formula for tension is a type of force only. So it is force, so it is ml t power minus 2. So C will match with 4. And D, which is surface tension, which is as surface tension is force by length. So that will be mt power minus 2. So D will match with 2. So it means that option A is the correct answer. Then it is told which of the following equations is dimensionally incorrect. T is time, h is height, s is surface tension, theta is angle, rho is density, a and r are radius, g is acceleration due to gravity, v is volume, p is pressure, w is work done, t is torque, epsilon is permittivity, E is electric field, J is current density, L is length. So here, which one is dimensionally incorrect? So here it is told V. V is volume. So volume is, it is told pi p a power 4 by 8 eta L. So it is actually the volume flow rate, pi p a power 4 by 8 eta L, and H is equal to 2s cos theta by rho g r, rho r g. And J, which is the current density, that is epsilon dE by dt. And W, that is work done, it is equal to tau into theta. So J, that is current density. Actually, it is the formula for displacement current. So epsilon will have the unit. Epsilon is epsilon is actually, we know that f is equal to q1 q square by 4 pi epsilon naught r square. So epsilon will have the dimension of q square by f r square. So therefore epsilon dimensional formula, that is I square t square. I means current, q is equal to it, so it is a square t square divided by ml cube t power minus 2. So this will be m power minus 1 l power minus 3 a square t power 4. So this is the dimensional formula for epsilon. And then dE by dt. E is actually f by l, f by q actually, force by charge, and T is there. So now if you do epsilon naught dE by dt, dou E by dou T, that will be equal to actually q square by f r square into f by q into 1 by t. So q and q will cancel, f and f will cancel. So that is coming q by r square into t. So it is q by t is current by r square. Yeah, it is charged by, it is coming current by area. So it is same as the current density. So this one is dimensionally correct. And h, as we know, 2s cos theta by rho g r. It is this formula is correct also. Since why h is the length, h is the height actually. So 2s. So s by rho g r. So s means surface tension, which is f by l into 1 by L, 1 by R is there, and rho is mass by volume, so it is m by L cube into, this is 1 by G. G is force by mass. So F will cancel, mm will cancel, L square, this will be L square by R, so which is same as H, which will be same as the dimensional formula for H. So this is dimensionally correct. And work done is tau into theta. This is also dimensionally correct, since why the dimensional formula for work is ml square t power minus 2, and torque also dimensional formula is r cross f, so it is ml square t power minus 2. So, and theta, which is angle, that is dimensionless. It is dimensionless. So it means this is dimensionally correct. So it means only v equal to pi p a power 4 by 8 eta L. This is not dimensionally correct. Since by pi p a power 4 by 8 eta L, this will, it's, it is called as the volume flow rate. So it is actually dv by dt. It means how much volume is flowing per unit time. So therefore, the dimensional formula for pi p a power 4 by 8 eta L, that will come volume by time. So it is L cube t power minus 1. This will come. And in the left hand side, it is written V is volume. So it is not dimensionally correct. So option A is the correct answer. Then here it is told you have to find the unit of the following. So Rydberg constant. So Rydberg constant, which is RH. So as we know that nu bar, which is wave number, that is equal to rz square into 1 by n1 square minus 1 by n2 square. So it means that the dimension z is the atomic number. So the dimensional formula for Rydberg constant RH, that is same as the dimensional formula for wave number, that is inverse of the length, L inverse. So it means it's unit will be meter inverse. So A will match with 3, and B, which is Planck's constant. So Planck's constant, as we know that lambda equals to h by p. So h will be equal to p into lambda, lambda into p. So therefore, it's the dimension. So h, its unit will be kg meter square per second. Since momentum unit is kg meter per second, and the SI unit of wavelength is meter, so it will be kg meter square per second. So B will match with 2, and C, which is magnetic field energy density, mu B. Mu B is called magnetic field energy density. Magnetic field energy density, mu B, that is magnetic field energy density, magnetic field. It is so it is the magnetic energy per unit volume. Magnetic energy per unit volume. So it will be magnetic energy. So its unit will be same as that of energy, which is ml square t power minus 2 divided by volume, which is L cube. So it will be ml power minus 1 t power minus 2. So therefore its unit will be kg per meter per second square. So option 4. So it means A will match with 3, B will match with 2, and C will match with 4. And D, which is coefficient of viscosity, it is um, viscous force by R into V. So it is kg meter per second square divided by, this is meter square per second. So this will be equal to kg per meter per second. So option 1. So D will match with 1. So option A is the correct. Yeah, no. Option B is the correct answer. And here it is told, if force, length, and time are taken as the fundamental quantities, then what will be the dimension of density? Force, length, and time are taken as fundamental quantities, then what will be the dimension of density? So density, that is equals to mass by volume. So its dimensional formula is ml power minus 3, and the dimensional formula for force is mlt power minus 2, and the dimensional formula for length is L, that dimensional formula for time is T. Now, so we have to find ml power minus 3. So we can do ml t power minus 2 divided by L square, no, divided by L power 4 into t power minus 2. So then we will get ml power minus 3. So therefore we can tell that rho, that is equal to force into time square divided by length power 4. So therefore the dimensional formula for density, that will be F into L power minus 4 into T power 2. Or we can solve it like this also. We can tell rho equals to, let's say, F power X, L power Y, T power Z. F rho is proportional to this. So it means their dimensional formula for rho, that is ml power minus 3 t power 0, that will be same as force power x, which is ml t power minus 2 power x into length power y to t power z. So therefore from here I can say it will be m power x into L power x plus y into t power minus 2x plus z. So therefore x will be equal to 1 if we compare the exponents, and x plus y that will be equal to minus 3, and z minus 2x that will be equal to 0. So z will be equal to 2x, means 2 into 1, that is 2, and y will be equal to minus 3 minus x. So it will be minus 3 minus 1, which is minus 4. So therefore density, the dimensional formula for density that I can say, it is f power 1 L power minus 4 and t power 2. So same answer we will get. So option A is the correct answer. Then here it is told which of the following is not a dimensionless quantity. Which of the following is not a dimensionless quantity? So relative magnetic permeability mu r, that is actually equal to mu by mu naught. So it is dimensionless. Dimensionless. And power factor, that is cos phi, which is called power factor in an AC circuit. So cos phi, as we know, that is equal to R by Z. So R is also, its unit is ohm, and for Z, which is called as the impedance, that is also, its unit is same as that of resistance. So cos phi is dimensionless, mu r is also dimensionless, and then permeability of free space, that is mu naught. So as you know, b square by 2 mu naught is equal to energy density, means energy by volume. So therefore permeability of free space, so magnetic energy per unit volume. So B is magnetic field. So we know that ILB, that is equal to the force. So B will be equal to F by IL, F by current into length. So B will be equal to force by current into length whole square divided by 1 by mu naught. That will be same as, that will be proportional. So its dimensional formula, that will be proportional to energy by volume. So energy is force into length. Simple, since why energy is has same dimension as that of work done, and volume is L cube. So from here we will get mu naught, that will its dimensional formula, that will be equal to F square by I square L square into L cube by FL. So F will cancel, L square L will cancel. So here we will get F by I square L. So it means that it is not dimensionless. Mu naught is not dimensionless. And quality factor, quality factor, quality factor or Q factor, that is equal to omega naught by 2 delta omega. So it is where it is, where omega naught is called as the resonant frequency divided by the bandwidth at resonance. So hence this also has the unit of frequency, and this one also, the bandwidth also has the unit of frequency. So it is also less. Quality factor is also dimensionless. So hence only the permeability of free space is not dimensionless, since why the dimensional formula for permeability of free space, that is equal to the dimensional formula for F by I square L. The dimensional formula for F by I square L. So F is the force, which is ml t power minus 2 divided by length into I square. I square means A square. So this will be m a power minus 2 t power minus 2. So hence option C is the correct answer. Then here it is told if E and H represents the intensity of electric field and magnetizing field respectively, then the unit of E by H will be equal to. So E is the electric field. So E, as we know, that is equal to the unit of the electric field is, it is force by charge. Force by charge. And H is the magnetizing field. Is equal to B by mu naught, I can tell. B by mu naught, yeah. So it is like for a solenoid, the magnetizing field is the magnetic field is mu naught Ni by mu naught. So this will be equal to Ni. N is the number of turns per unit length. So it is like I by L. So therefore E by H will have the same dimension. Its dimensional form, the dimensional formula for E by H, that will be equal to F by Q, the dimensional formula for F by Q by the dimensional formula for I by L. So this will be equal to FL by QI. So dimensional formula for FL by QI. So this is Q into I. FL is energy. I, so it is MLT power minus 2 into L by charge is I into T, and this is into I. So this will be ml square T power minus 3 to I power minus 2. Now the unit of resistance, the dimension of resistance is voltage by current. Now voltage is work done by charge, which is work done FL by Q into I, FL by QI. Yeah. So it means that E by H has the same dimensional formula as that of resistance. So it means the unit of E by H also will be ohm. And the unit, since why the unit of uh, resistance is also ohm. So since it has the same dimensional formula as that of E by H, so its unit should be also ohm. So option A is the correct answer. Then it is told to find the dimensional formulas of magnetic induction, magnetic flux, magnetic permeability, and magnetization. So magnetic induction. So magnetic induction, magnetic flux, okay, magnetization. Yeah. So magnetic flux, first we can do magnetic flux. So magnetic flux is phi b. Phi b is equal to B into A, which is magnetic field, which is B dot A, magnetic field into area. So therefore the dimensional formula for phi b, that will be B magnetic field, I can say it is F by IL, force by force by current into length. So it is force by current into length and into L square. So that will be equal to FL by I, which is work done. So it is ml square t power minus 2 by I. So it is ml square t power minus 2 a power minus 1. So it means that B will match with 1. B will obviously match with 1. And then B will match with 1. And then magnetization. So it means that A and B, C is wrong. And only we have to check in between B and D. And C is also same in A and D. So C should match with 4. And also we can prove that since magnetic permeability, that is mu. So mu, as we know, that is equal to mu equals to, so as you know, B square by mu naught, or I can say mu naught Ni, that is equal to magnetic field, which is F by IL, and so mu naught is equal into N by Ni by L. So N is the number of turns and L is the length, F by IL. So L will cancel. So then mu naught will have the same dimension as that of F by I square. So the dimensional formula for mu naught, that is mlt power minus 2 a power minus 2. So C will obviously match with 4. And D is magnetization. Magnetization, that is magnetization, I can call it as M1. So that is the magnetic moment per unit volume. Magnetic moment per unit volume. So magnetic mo moment is like NIA, I into A by volume, which is L cube. So therefore, the dimensional formula for magnetization, that will be equal to current into area. So current, so IL square by L cube. So that is equal to I by L, IL inverse. So the unit of the dimension of magnetization, that will be equal to current AL inverse. AL inverse, AL inverse and into M power 0. So L inverse A, L inverse A, M power 0 L inverse A. So it means that uh, D will match with 2. D will match with 2. So it means that option D is the correct answer. D is the correct answer. So it means A will match with 3, magnetic induction. Okay. So here it is told that the acceleration due to gravity is found up to an accuracy of 4% on a planet. The energy supplied to a simple pendulum to known mass m to undertake oscillations of time period t is being estimated. If time period is measured to an accuracy of 3%, the accuracy to which E is known as. So now when a simple pendulum is oscillating to and fro, so then here the the total energy, the total energy of oscillation, the total energy of oscillation, which is E, that is given as half ka square, where a is the amplitude of oscillations And here the amplitude of oscillations, that will be equal to L theta, where theta is the maximum angular displacement. Theta is the maximum angular displacement. And L is the length of the string. And K is equals to root over G by L, where L is the length of the string. So now, therefore, the total energy of oscillations, that will be equal to half K. Now, no, sorry, there is something wrong. Omega equals to root over G by L. Omega is the angular speed, or omega is called the angular frequency of oscillation, angular frequency. So that is root over G by L. And K that is equals to m omega square. K equals to m omega square. So it will be mg by L. It will be half mg by L into a square, which is L square theta square. So then we will get mgl theta square by 2. So this is equal to the total energy of oscillation. And here uh, the time period of oscillation, that is equals to 2 pi by omega, which is equal to 2 pi root over L by G. So therefore L, so if we take square on both sides, then we will get T square equals to 4 pi square L by G. So therefore L can be written as 4 pi square T square by no 4 pi square G by T square. 4 pi square no, L equals to actually gt square by 4 pi square. Gt square by 4 pi square. So now, therefore, in place of L, we can substitute this expression with G and T, since here the length of the pendulum has not been told. So therefore, the total energy of oscillation, that is equal to mgl theta square by 2. So that will be equal to mg by 2 into theta square into L. L is gt square by 4 pi square. So therefore, the energy, that will be equal to m by m theta square by 8 pi square, m theta square by 8 pi square into g square t square. So now here it is told that the mass is known, so it is a known mass, and so this m theta square by 8 pi square, it will be a constant. So therefore I can tell the total energy of oscillation, that is proportional to g square t square. So therefore the percentage error in the measurement of the energy that is supplied, the percentage error in the energy that is supplied, that will be equal to twice of the percentage error in the calculation of G plus twice of the percentage error in the calculation of the time period of oscillation. So this will be equal to twice of the percentage error in G, that is 4%, plus twice of the percentage error in time period, that is 3%. So this will be 8 plus 6%, so that is equal to 14%. So the accuracy to which E is known will be 14%. And here it is told student A and student B use 2 screw gauges of equal pitch and 100 equal circular divisions to measure Student A and student B use two screw gauges of equal pitch, and and 100 circular divisions to measure the radius of a given wire. The actual value of the radius of the wire is 0.322 centimeter. The absolute value of the difference between the final circular scale readings observed by the students A and B is given pitch is figure shows position of reference O when jaws of the screw gauge are closed. Okay. Circular scale readings. Okay, so then here for the student A, the circular scale reading, that is 5 into this will be actually 5 into the least count error. Now the least count is the pitch 0.1 centimeter divided by the number of circular scale divisions, that is 100, so it will be 0.001 centimeter. So the circular scale reading for the student A, that will be 5 into 0.001 centimeter, so that is 0.005 centimeter. And the circular scale reading for the student B, that will be equal to, it is coinciding at the 90-second mark on of the vernier scale. So therefore it will be 92 into 0.001 centimeter, which is 0.092 centimeter. So therefore the difference in between the circular scale readings of the student B and the student A, that will be equal to 0.092 centimeter minus 0.005 centimeter. So that will be equal to 0.067, is 8. So it is 0.087 centimeter. So the absolute value of the difference in between the final circular scale readings observed by the students A and B, that will be equal to 0.087 centimeter. Then here it is told 3 students S1, S2 and S3 perform an experiment for determining the acceleration due to gravity G using a simple pendulum. They use different lengths of pendulum and record time for different number of oscillations. The observations are shown in the table. The least count of length, that is 0.1 centimeter, and least count for time is 0.1 second. So if E1, E2 and E3 are the percentage errors in G for students 1, 2 and 3 respectively, then the minimum percentage error is obtained by the student number. So the percentage error in G for student 1, that is E1, so that is actually delta G by G into 100, that will be equal to, as you know, T equals to 2 pi root under L by G, so T square will be 4 pi square L by G. So G will be equal to 4 pi square L by T square. So it means delta G by G into 100%, that will be equal to delta L by L into 100% plus, which is the percentage error in the length, plus uh, twice of delta T by T into 100, which is the percentage error in the measurement of time period. So now E1, that is the percentage error in G for the student 1. So that will be equal to the percentage error in length of the student 1. So as we can see, student 1 performed 8 oscillations. So the least count, so the error will be lesser, which will be 0.1 by 8, 0.1 centimeter by 8 into the length. No, no, mm, no, length, it will be 0.1 only. And the length of the pendulum is 64 centimeter into 100%, plus it is twice of delta t by t into 100. So delta t is the time interval, so which is the least count for the time, that is 0.1 second. But since 8 oscillations have been made, so the error, the absolute error in time, that will be 0.1 by 8, and the time period which he has found, that is 16 seconds. So it is 0.1 seconds. Okay. Yeah, into 100%. So this will be equal to 10. This is 10 by 64% plus 2 4 is 8. So this is also 10 by 64. So this is equal to 20 by 64%, which is 5 4 5 is 20, 16 4 is 64. So 5 by 16%. And E2, that is the percentage error in G for the student 2. So that will be also 0.1 by 64 into 100%. That is the percentage error in the length, plus twice of the percentage error in the time. So he performed uh, he has performed 4 oscillations. So the least count error, that will the least count error will be 0.1 by 4, 0.1 by 4 into the time period which he has found, that is 16 into 100%. So this will be equal to 10 by 64 plus this is 2, 2 is a 4. So it is 10 by 32. So, or we can say 10 by 64 plus 20 by 64. So that is 30 by 64%. So that will be 15 by 32%. And this we can say it is also 10 by 32%. And E3, which is the percentage error in G for the student 3. So that will be 0.1 by the length of the pendulum is 20 into 100%, plus that is twice of the percentage error in time. So that is time period he has found, that is 9. So he has performed 4 oscillations. So that is 0.1 by 4 is the least count error, and time period is 9 into 100%. So this will be equal to 2 to the 4. So this will be 10 by 20% plus this is 10 by 18%. So this will be equal to 1 by 2 plus 10 by 18, that is 18 is the LCM. 2 9s 18, 9 plus 10, that is equal to 19 by 18%. 19 by 18%, which is 1 point something. So it is more than 1%. And here it is told then the minimum percentage error is obtained by the student. So the minimum percentage error is obtained by the student 1, since it is 10 by 32%. So the answer will be the first student has obtained minimum percentage error. Then here it is told the radius of a sphere is measured to be, the radius is 7.5 plus or 7.50 plus or minus 0.85 centimeter. Suppose the percentage error in its volume is x, the value of x to the nearest x is okay. Okay, so here the absolute error in the radius is 0.85 centimeter. So now volume, as you know, that is equal to 4 by 3 pi r cube for a sphere. This is the volume of a sphere. So therefore the percentage error in the volume, that is delta v by v into 100, that will be equal to the 3 times the percentage error in the value of r, value of the radius of the sphere. So that will be equal to 3 into, so this is equal to x, which they have asked. So x will be equal to 3 into delta r, which is 0.85 centimeter by 7.50 centimeter into 100%. So this will be equal to 3 into 85 by 75, 750 into 100. So 0, 0 will cancel. Then this is 5 ones are 5, 5 fives are 25, 15 fives are 75, 5 twos are 10, then 5 threes are 15, 5 ones are 5, 5 sevens are 35. Then 3 will cancel. So this is equal to 34%. So it means the percentage error in the volume is x. So x will be equal to 34. 34%. Then here it is told the resistance R equals to V by I. So then V is given as this 50 plus minus 2 volt, and I is equal to 20 plus or minus 0.2 ampere. So the percentage error in R is x%. The value of x to the nearest integer is. So therefore delta R by R into 100%, which is the percentage error in the measurement of the resistance R, which is equal to x, which we have to find out. So that will be equal to delta V by V into 100%, which is the percentage error in the measurement of voltage, plus delta I by I into 100, that is the percentage error in the measurement of current. So this will be 2 by 50 into 100%, plus this will be delta I, that is 0.2 by 20 into 100%. So this will be equal to 50 to the 100, 25 the 100, 2 to the 4%, and this is 1%. So this is equal to 5%. That means option, so X will be equal to 5. So hope all of you have understood the solutions of all these questions based on the previous year JEE mains, based on the chapter units and measurements. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application, where we shall upload some important homework questions based on the previous year based on the previous year exam. So thank you everyone. Bye. So here it is told that if the length of the pendulum in pendulum clock increases by 0.1%, then the error in time per day is. So as you know, t equals to 2 pi root over L by G. So it means that t is proportional to root L. So therefore I can say the error in the time per day, that is delta t by t, that will be equal to half of delta L by L, which is, so the relative error in the measurement of time, that is equal to half of the relative error in measurement of length. So the length of if the length of the pendulum increases by 0.1%, so it means that delta L by L into 100, that is equal to 0.1%. It means that delta L by L, that will be equal to 0.1 by 100. So that will be 0.001. So therefore, delta T, that will be equal to T by 2 into delta L by L, which is 0.001. So the error in time per day. So as you know, one day is 24 hours, or you can say 24 into 3600 seconds. So therefore, if the time is 1 day, that is 24 into 3600, so that by 2 into 0.001. So that will be equal to the error in time per day. So this will be 12. So it is 12 into 3600 into 0.001. It means 1 by 1000. So it is 12 into 3.6. So it is 12, 6 is 72. 12 is 36, 36 plus 7. 36 plus 7, that is equal to 43. So 43.2 seconds. So 43.2 seconds in the is the error in time per day. So option C is the correct answer. Then here it is told, in a screw gauge, fifth division of the circular scale coincides with the reference line when the ratchet is closed. There are 50 divisions on the circle. So when the ratchet is closed, fifth division of circular scale coincides with the reference line. It means that the zero error will be equal to 5 into the least count of the screw gauge. Now 50 divisions are there on the circular scale, and the main scale moves by 0.5 millimeter on a complete rotation. So therefore, the pitch of the screw gauge is 0.5 millimeter, and the number of circular scale divisions equal to 50. So now, therefore, the least count, that will be equal to pitch divided by number of circular scale divisions. So pitch is 0.5 millimeter divided by 50. So this will be equal to 0.01 millimeter. 0.01 millimeter. Then for a particular observation, the reading on the main scale is 5 millimeter, and the 28th division of the circular scale coincides with the reference line. So it is told for a particular observation, the reading on the main scale. So main scale reading is 5 millimeter, and the circular scale reading, that will be equal to, here it is told 20th division on the circular scale coincides with the reference line. So it is 20 into the least count. So that will be 20 into 0.01 millimeter. So therefore it is 0.2 millimeter. And the zero error is 5 into the least count. So 5 into 0.01 millimeter, which is 0.05 millimeter, which is a positive zero error. So now, therefore, the true reading. So the true reading, that will be equal to the observed reading minus the zero error. Now observed reading, that is equal to the main scale reading plus the circular scale reading minus the zero error. So the main scale reading, that is 5 millimeter, plus the circular scale reading, that is 0.2 millimeter, and minus the zero error, that is 0.05 millimeter. So therefore, the reading will be, so it is 5.20 millimeter minus 0.05 millimeter, which is 5.15 millimeter. So 5.15 millimeter is the true reading. So option C is the correct answer. And here it is told, if E, L, M, and G denote the quantities as energy, angular momentum, mass, and constant of gravitation respectively, then the dimension of P in the formula, P equals to EL square M power minus 5 G power minus 2 R. The dimensions of P in this formula is, so the dimension of P is equal to the dimension of energy into the dimension of angular momentum L square into the dimension of mass power mm, minus 5 into the dimension of G power minus 2. So E is energy, so its dimensional formula is ml square T power minus 2, and the unit the dimension of angular momentum, that is r cross p, so it is ml square T power minus 1, and mass power minus 5, and this will be L square, and into G, the universal gravitational constant, which is G equals to Fr square by M square. So therefore, the dimensional formula for G is ml square T power ml T power minus 2 into L square by M square. Okay. That is ml t power minus 2 into L square by m square. So it will be m power minus 1 L cube t power minus 2. It is m power minus 1 L cube t power minus 2 whole power minus 2. So therefore, the dimensional formula for P has been asked. So that will be m, that will be equal to m power, that is 2 plus 2 minus 6. No, this is square. So this will be m 1 plus 2 minus 5 plus 2 minus 5 plus 2 into L power 2 plus 4 minus 6, which is 2 plus 4 minus 6, and into t power minus 2 minus 2 minus 2 minus 2 plus 4 minus 2 minus 2 plus 4 minus 2 minus 2 plus 4. So this will be equal to 0. So it is m power 0 into L power 0 into t power 0. So it means that option D is the correct answer. Then here it is told that a physical quantity y is represented by the formula y equals to m square r power minus 4 g power x L power minus 3 by 2. So here it is told that the percentage errors found in y, m, r and r, l and g, y, m, r, l and g are 18, 1, 0.54 and p respectively. Then the value of x and p is okay. So therefore here we can say that delta y by y into 100, which is the percentage error in the value of y. So that will be equal to 2 into percentage error in m plus 4 into percentage error in r four into percentage error in r plus x into percentage error in g plus 3 by 2 into percentage error in L. So therefore this percentage error in y, that is 18, and this percentage error in m, that is 1, so it will be 2 into 1% is 18% plus 4 into the percentage error in r, that is 0.5. Okay, it is percentage error in r is 0.5. Percentage error in r is 0.5, 0.5% plus x into percentage error in g, that is equal to p percent plus 3 by 2 into the percentage error in L, that is 4. Then here it will be 18 will be equal to 3 plus 2 plus px plus 2 twos of 2 twos of 4 2 to 6. So therefore px will be equal to 18 minus 5 plus 6, that is 11. So px will be equal to 7. And x can be negative or positive also. X can be negative or positive also. So therefore, actually px can be equal to plus or minus 7. Px that is equal to 7. P actually that is for G. Sorry, P is for G. Yeah, P is the percentage error in G. So Px equal to 5, okay, 11, so 7. Okay, sorry. So this will be 2. 2 plus 2 plus Px plus 6. So this will be 10. So Px should be equal to 8. And since x can be positive or negative, so Px should be plus or minus 8. So now in all the options, the product of x and p that should be uh, that should come plus or minus 8, which can happen only in option C. Since in A and B their product is coming plus or minus 10, here it is coming plus or minus 12, here only it is coming plus or minus 8, here it is coming plus or minus 16. So only option C is the correct answer. And here it is told, if in 5 complete rotations on the circular scale, the distance traveled on main scale of the screw gauge is 5 m- m- millimeter, and there are 20 total divisions on circular scale, then least count is 0.001 centimeter. So least count, as you know, it is pitch divided by the total number of circular scale divisions. So least count of the screw gauge, that is pitch. Here it is told that uh, in 5 complete rotations, in 5 rotations, it the main scale travels 5 millimeter. So therefore, the pitch will be equal to 5 millimeter divided by number of rotations. So that is 1 millimeter, which means it is 0.1 centimeter. So the least count will be 0.1 centimeter divided by, there are 50 divisions on circular scale. So that will be 50. So this will be equal to 1 by 500. So this is actually equal to 0.2 by 100, which is 0.002 centimeter. So it means the least count is 0.002 centimeter. And so A is not correct, but R is correct, since the reason is told the least count is pitch by total divisions on circular scale. So the reason is correct, but the assertion is wrong. So option A is the correct answer. Then here it is told the force is given in terms of time t and displacement x by the equation a cos a the food is the sorry the force is given in terms of t and displacement x. So t is the time, x is the displacement. Then they are asking the dimensional formula for AD by B. Now, a force that is given as A cos bx plus C sine dt. So the angle which is there inside the cos function or in the sine function, that should be dimensionless. So it means that B into x, that will have the dimension, that will be dimensionless, and x is the displacement. So the dimensional formula for B, that will be equal to the dimensional formula for 1 by x, which is equal to inverse of the length, L inverse. And similarly, dt will be also dimensionless. So it means that the dimensional formula for d will be equal to the dimension of 1 by t. So it will be equal to t inverse. So the dimensional formula for d is t inverse, and ad by, so a the dimensional formula for a will be same as the dimensional formula for c, which is same as the force, which is same as the dimensional formula for force. So therefore, the dimensional formula of A is equal to ml t power minus 2, which is same as the dimensional formula for F. So now, therefore, the dimensional formula of AD by B is, therefore, the dimensional formula for AD by B, that will be how much? That will be equal to A, that is ml t power minus 2 into D. D is T inverse divided by B, that is L inverse. So this will be equal to ml square t power minus 1. So this is the dimensional formula for AD by B. ml square t power, sorry. So this is minus 2 into minus 1. So this will be minus 3. ml square t power minus 3. So option B is the correct answer. Then here it is told if time t, velocity v, and angular momentum L are taken as the fundamental units, then the dimension of mass m in terms of t, v, and L is. So as you know, angular momentum, that is L, that is given as mvr. It means mass into velocity into mass into velocity into the length from the axis of ro- rotation. It means L equals to mvr, I can say. So now this length also, this length which is r, I can also tell it is same, having same dimension as velocity into time. So I can say that the dimensional formula for angular momentum L, that will be equal to mv square t. That will be equal to the dimensional formula for mv square t. So therefore, the dimension of mass, that will be equal to L by v square t. So therefore, the dimensional formula for mass, I can say it as, it will be t inverse v power minus 2 into L power 1. T inverse v power minus 2 L power 1. So it means option D is the correct answer. Then here it is told that the vernier scale used for measurement has a positive zero error. It has a positive zero error of 0.2 millimeter. If while taking a measurement, it was noted that 0 on the vernier scale lies in between 8.5 centimeter and 8.6 centimeter. Vernier coincidence is 6. Then the correct value of the measurement is, then it is told that if while taking a measurement, it was noted that 0 of the vernier scale lies in between 8.5 and 8.6 centimeters. So therefore the main scale reading is 8.5 centimeter and vernier coincidence is 6. Then the correct value of the measurement is, the least count is given as 0.01 centimeter. So therefore zero error, I can say it as it is 0.02 centimeter. So therefore the observed reading or the correct reading, no, the observed reading, or I can say the calculated reading, that is equal to the main scale reading plus the vernier scale reading. So main scale reading is 8.5 centimeter plus vernier scale reading, that will is equal to the vernier constant into the least count, which is, or I can say the vernier coincidence into the least count. So it will be 8.5 centimeter plus 6 into 0.01 centimeters. So this will be equal to 8.56 centimeter. Now least count is 0.02 centimeter. Therefore, the correct value of the measurement, the correct value of the measurement, that will be equal to the observed reading or the observed value minus the zero error. Minus the zero error. So observed reading is equal to 8.56 centimeter minus the zero error, which is 0.02 centimeter. 0.02 centimeters. So this will be equal to 8.54 centimeter. So option B is the correct answer. Okay. Then it is told that in order to determine the Young's modulus of a wire of radius 0.2 centimeter measured using a scale of least count 0.001 centimeter and length 1 meter measured using a scale of least count 1 millimeter. So here the least count for the measurement of radius, or I can say it is delta r, which is the m- maximum e- error, the maximum absolute error in m- measurement of the radius. So that is equal to 0.001 centimeter, and the length, that is 1 meter, which is measured using a scale of least count 1 millimeter. So therefore delta L, that will be equal to 0.01, no, 0.1 centimeter, 0.1 centimeter, which is 1 millimeter also I can tell, and weight, a weight of mass 1 kg was hanged to get the elongation of 0.5 centimeter. So the weight, which is the mass m, that is 1 kg, and the least count of the scale, which is delta m, that will be equal to 1 gram. So the mass is 1000 gram, and the error in the mass will be 1 gram. Was hanged to get a elongation of 0.5 centimeter, 0.5 centimeter. So now the Young's modulus of a wire, how to find it, will be force by area divided by delta L by L, where delta L is the elongation. So let's say the elongation, we call it as some constant d, suppose. Let's say d is the elongation of the rod. And A is the area of cross section of the wire. And force is where actually it is hanged. It is hanged by uh, so at one end of the wire m- mass is hanged whose mass is 1 kg. So the Young's modulus of this where we have to find. So here the tension force or the force which is applied, F will be equal to mg. So therefore here the elongation of the wire, elongation let's call it as d, that is equal to 0.5 centimeter, and which is measured using a scale of least count 0.001 centimeter. So therefore delta d, that would be equal to 0.004. No, delta d is the least count of the instrument which is used to measure the elongation of the rod. So d will be 0.001 centimeter. Then what will be the fractional error in the value of Young's modulus determined by this experiment? We have to find the fractional error in the value of the Young's modulus which is determined by this experiment. So it means we have to find delta y by y. This we have to find fractional error, or actually here the options are given in percentage. So it means we have to find delta y by y into 100. We have to find this delta y by y into 100%. That value we have to find out. So therefore now F, I can say that will be equal to F force which is mg by A, which is pi r square. Since the wire should have a cylindrical cross section, so y is equal to F by A, which is pi r square, into L by D. L by D. D is the elongation, and L is the length. And here force, the force applied is mg actually. And here g and pi, these are constants. F is equal to mg, where m is the mass of the object which has been hanged at one end of the wire to ob obtain the elongation of the rod. So therefore, now therefore y is m, this g by pi, this is a constant. So therefore we can say the Young's modulus of the wire, that is proportional to ml by r square into d. So therefore the percentage error or the fractional error in the measurement of y, that will be delta y by y into 100%, which will be equal to delta m by m into 100% plus delta L by L into 100% plus delta D by D into 100% plus 2 into delta R by R into 100%. 2 into delta R by R into 100%. So this is equal to the relative error in measurement of mass. So delta m is 1 gram. So it is 1 by 1000. 1 by 1000. 1 gram is the least count of the scale which is used to measure the weight. So 1 by 1000 into 100% plus this is delta L, that is 0.1 centimeter. So 1 meter, it means it is 100 centimeter. So delta L by L, which is 0.1 centimeter divided by 100 centimeter into 100%. Then plus this will be delta D, that is 0.001 centimeter divided by 0.5 centimeter into 100%. Plus it is 2 into 2 into delta R by R. So radius is 0.2 centimeter and the least count is 0.001 centimeter. So it is 0.001 by 0.2 into 100%. 0.2 into 100%. So therefore this will be equal to, this will be 1 by 10, that is 0.1%, plus this is also 0.1%, plus this will be equal to the 100 into this, that is 0.1, so it is 1 by 5. 1 by 5, so that is 5 2s are 10, so 0.2%, plus this is also 0.1, so this is half into 2, that is 1%. So therefore it is 1.2 plus 2 4, 1.4%. So 1.4% error is there. 1.4% error in the value of the Young's m- m- in the Young's modulus will be there. So option C is the correct answer. Then here it is told one main scale division of a vernier caliper is A centimeter. So one main scale division is A centimeter and nth division of vernier scale coincide with n minus 1th division of the main scale. So it means n vernier scale divisions equals to n minus 1 main scale divisions. The least count of the calipers in millimeter is okay. So it means that one vernier scale division, that is equal to n minus 1 by n main scale divisions. So it means it is n minus 1 n into A centimeter. So therefore the least count, that is equal to one main scale division minus one vernier scale division. So that is equal to one main scale division, that is A centimeter, minus one vernier scale division, that is n minus 1 by n into A centimeter. So this will be equal to, so A I can take as common and then we can write 1 minus n minus 1 by n centimeter. So this will be equal to A into 1 by n centimeter. So in millimeter, 1 centimeter is 10 millimeter, as you know. So this will be 10 A by n millimeter. 10 A by n millimeter. So option A is the correct answer. Then here it is told if C and V represent capacity and voltage respectively, then what are the dimensions of lambda where C by V equal to lambda? So now C is the capacitance. As we know that charge Q equals to C into V. Charge Q equals to C by C. So C by V. So I can say C equals to actually Q by V. So therefore C by V, that will be equal to Q by V square. So therefore C by V, that is lambda. So therefore the dimensional formula for lambda, that is same as the dimensional formula for Q by dimensional formula for V square. So dimensional formula for Q is I into T. Charge into means current into time is charge. by V square. V is actually the voltage. Voltage is work done by charge. Voltage is work done by charge. So therefore, its dimension, the dimensional formula for voltage will be ml square t power minus 2 divided by it. So this will be ml square t power minus 2 divided by it, its whole square. So therefore, the dimensional formula for lambda, that will be equal to it, which is charge, divided by m square l power 4 t power minus 4 by I square t square, v square it is. So therefore, it will be I cube t cube divided by m square l power 4 t power minus 4. So therefore, it will come m power minus 2 l power minus 4 I power 3 t power 7. So m power minus 2 l power minus 4 I power 3 t power 7. So option C is the correct answer. Then here it is told, in a typical combustion engine, the work done by a gas molecule is given by W equals to alpha square beta alpha square uh, beta E power minus beta x square by kt, where x is the displacement. X is the displacement, K is the Boltzmann constant, and T is the temperature. If alpha and beta are constants, dimensions of alpha will be. Now, therefore, the dimension of the beta x square by kt, that will be 1, means it will be dimensionless, that is m square l power m power 0 l power 0 t power 0. So it means that the dimensional formula for beta, the dimensional formula for beta is the dimensional formula for kt by x square, where x is the displacement, and kt is will have the dimension of energy. It will have the dimension of energy or work done by x square. So this will be equal to ml square t power minus 2 by l square. So this will be, therefore, the dimensional formula for beta, dimensional formula for beta is l square will cancel, so that is m t power minus 2. And then the dimensional formula for alpha square beta is same as the dimensional formula for work. Dimensional formula for work is same as dimensional formula for alpha square beta. So therefore, the dimensional formula for alpha square, that is same as the dimensional formula for W by beta. So dimensional formula for W by beta is same as alpha square. So dimensional formula for alpha square, that will be W, that is ml square t power minus 2 divided by beta, that is m t power minus 2. So m will cancel, t power minus 2 will cancel. So therefore, alpha square has the dimension of L square. So therefore, alpha will have dimension of the length L. So alpha will have dimension of length. So therefore, the dimensional formula for alpha is m power 0 L t power 0. So option A is the correct answer. Then here it is told, if E is the electronic charge, C is the speed of light in free space, H is Planck's constant, then the quantity E is mod E square by 4 pi epsilon naught HC has the dimension of. So as we know that according to the Coulomb's law, the electrostatic force is given as Q square by Q1 Q2 by 4 pi epsilon naught R square. So therefore, the dimension of 1 by 4 pi epsilon naught is same as F into R square by q square. So therefore, the dimensional formula for 1 by 4 pi epsilon naught, that is equal to force, that is ml t power minus 2 into L square divided by charge square. So that is I square t square. So this will be ml power 3 I power minus 2 t power minus 4. So E square by hc. Planck's constant. So the dimension of Planck's constant is lambda into p, where lambda is the de Broglie wavelength, p is the momentum. So therefore that is same as L m L square t power minus 1. And c is the speed of light. Its dimensional formula is L t power minus 1. So now, therefore, we have to find the dimensional formula for mod E square by 4 pi epsilon naught hc. So that will be same as the dimensional formula for E, that is charge E square by the dimensional formula for H, dimensional formula for C, into the dimensional formula for 1 by 4 pi epsilon naught. So now, therefore, E square, that is I square T square, which is charge is current into time, into dimension of 1 by 4 pi epsilon naught is ml cube I power minus 2 t power minus 4 divided by h, that is ml square t power minus 1 into c is l t power minus 1. So m will cancel out, L square and this will cancel, t power minus 1. Okay. L square and L cube is also there. So L and L will also get cancelled. So this is coming I square, okay, I power minus 2. So I power minus 2. So 2 minus 2, this will also get cancelled. So this is t power 2 minus 4 plus 2. So this will be t power 0. So it means this is dimension less. So is mod E square 4 pi epsilon naught hc is dimensional formula is m power 0, L power 0, t power 0. So it is dimension less. So option C is the correct answer. And here it is told to find the dimensional formulas for these physical quantities. So here H, the dimensional formula for Planck's constant is same as the dimensional formula of lambda into P. So that will be ml square t power minus 1. And then the dimensional formula for kinetic energy is same as that of work done, which is force into length, is ml square t power minus 2. And the dimensional formula for electric potential, that is equal to work done by charge. So that will be ml square t power minus 2 divided by charge, which is it. So that will be ml square I minus 1 t power minus 3. So it is the dimensional formula for electric potential. Dimensional formula for electric potential. And then the dimensional formula for linear momentum. Dimensional formula for linear momentum, that is mass into velocity. So it is mlt power minus 1. So it means that A will match with 2, B will match with 3, and C will match with 4. C will match with 4, and D will match with 1. So 2341, 2341. So option A is the correct answer. Then here it is told the pitch of the screw gauge is 1 millimeter. So pitch is 1 millimeter, and there are 100 divisions on the circular scale. So number of circular scale divisions is 100. When nothing is put in between the jaws, the zero of the circular scale lies 8 divisions below the reference lines. Therefore here we have positive zero error. Therefore the positive zero error, that is equal to 8 times the least count. And when a wire is placed in between the jaws, the first linear scale division is clearly visible, while 72nd division on circular scale coincides with the reference line. The radius of the wire is. So the first linear scale division is clearly visible. Therefore, the main scale reading is 1 millimeter, and therefore the least count, that will be pitch by the number of circular scale divisions. So that will be 1 millimeter by 100, that is equal to 0.01 millimeter. So therefore the zero error, the positive zero error, that will be equal to 8 into 0.01 millimeter. So that is 0.08 millimeter. So this is the zero error. This is the positive zero error. And then the reading we have to find. So therefore the observed reading, yeah, zero of the circular scale when a wire is placed into the jaws. So here actually we are measuring the diameter of the wire. We are measuring the diameter of the wire. So here the radius has been asked. So the radius will be half of the diameter of the wire. So therefore here the observed reading, that will be equal to the main scale reading plus the circular scale reading. So the main scale reading is 1 millimeter plus the circular scale reading is 72nd division on circular scale coincides. So 72 into the least count. So it is 1 millimeter plus 72 into 0.01 millimeter. So that is 1.72 millimeter. And therefore the actual diameter of the wire, actual or the correct diameter of the wire, that will be equal to the observed reading minus the least count. Observed reading of the diameter of the wire minus the least count. So observed reading is 1.72 millimeter minus the least count, which is 0.08 millimeter. So 1.72 minus 0.08 millimeter, so that will be 1.64 millimeter. 1.64 millimeter. So 1.64 millimeter is the diameter. So then therefore the radius of the wire, that will be equal to half of this diameter of the wire, which is 1.64 millimeter. That will be 0.82 millimeter. 0.82 millimeter. So option C is the correct answer. Then here it is told the work done by a gas molecule in an isolated system is given as W equal to alpha beta square e power minus x square by alpha kt, where x is the displacement, k is the Boltzmann constant, t is the temperature, and alpha and beta are constants, and the dimension of beta will be the dimension of beta we have to find. So here x square by alpha kt will be dimensionless. So it will be dimensionless, which is m power 0, l power 0, t power 0. So therefore, the dimensional formula for alpha, that will be equal to the dimensional formula for alpha k, will be same as the dimensional formula for x square by kt. So x square is displacement, so it is L square by k. X is displacement, so x, the dimensional formula for x square will be L square, and kt will be the same as the dimensional formula for energy. It is called thermal kinetic energy. Thermal kinetic energy, so it will have the same dimension as that of work done, which is ml square t power minus 2. L square will cancel. So therefore, the dimensional formula for alpha, that is m power minus 1 t power 2. And then also the dimensional formula for work done, that is same as the dimensional formula for alpha beta square. So now therefore, the dimensional formula for alpha beta square, that will be same as that of work done, that is ml square t power minus 2. And the dimension formula for beta square, that will be equal to ml square t power minus 2 divided by the dimension of alpha. So that will be ml square t power minus 2 divided by the dimensional formula for alpha, which is m power minus 1 t square. M power minus 1 t square. So therefore, the dimension of beta square, that is equal to m square l square t power minus 4. So therefore, the dimensional formula for beta, the dimensional formula of beta is square root of this, which is mlt power minus 2, which is same as that of the force, mlt power minus 2. So option C is the correct answer. Then here it is told that the diameter of a spherical bob is measured using vernier calipers. 9 divisions on the main scale in the vernier calipers are equal to 10 divisions on vernier scale. So 10 vernier scale divisions equal to 9 main scale divisions, and 1 main scale division, that is equal to 1 millimeter. 1 millimeter is 1 main scale division, and the main scale reading is 10 millimeter, and 8th division on vernier scale was found to coincide exactly with one of the main scale division. So the vernier coincidence is 8 here. So therefore, the vernier scale reading will be 8 into the least count. If the given vernier calipers has positive zero error of 0.04 centimeter, then the radius of the bob is. So here we have to find the diameter of the wear first, which is the correct diameter of the wear, and that we have to find, and then we have to find the radius of the bob, which is half of the diameter of the wear. So now, therefore, here the least count, that will be equal to 1 main scale reading minus 1 vernier scale reading. So which is 10 millimeter is 1, no, 1, sorry, this is wrong. Least count is 1 vernier scale division minus 1 main scale division minus 1 vernier scale division. So from here you can see 1 vernier scale division will be equal to 0.9 main scale division. It means 1 main scale division is 1 millimeter, so 1 vernier scale division is 0.9 millimeter. So the least count is 0.1 millimeter. So therefore, the vernier scale reading is 8 into the least count. So 8 into 0.1 millimeter, that is 0.8 millimeter. This is the vernier scale reading. So now we have to find the observed reading. Observed reading is main scale reading plus vernier scale reading. So main scale reading is 10 millimeter plus the vernier scale reading, that is 0.8 millimeters. So the observed reading is 10.8 millimeter, and therefore the correct reading or the correct diameter of the wire, that will be equal to the observed reading minus the zero error. Observed reading minus the zero error. Observed reading minus the zero error. So observed reading is 10.8 millimeter minus the zero error, which is 0.04 millimeter. 0.04 centimeters. Okay, so the zero error is 0.04 centimeters. So we have to convert it into millimeters. So that is 10.8 millimeter minus 0.4 millimeter. So that is 10.4 millimeter. So now therefore the radius of the wire, radius of the spherical bob actually. So radius of the bob, that is half into the correct diameter, which is 10.4 millimeter, which is 5.2 millimeter. So 5.2 millimeter is the radius of the wire, radius of the bob. So this we have to convert into centimeters. So this is 0.52 centimeter, or we can write it 52 into 10 power minus 2 centimeter. So the radius is 52 into 10 power minus 2 centimeter. So in the blank space, we should write 52. Okay.